Inverse of quadratic function. Determine inverse of the function y equals to x plus 1 whole square. Explain how you can restrict the function to ensure that its inverse is also a function. So as we did in the previous video, we'll again find the inverse of the function and see how to restrict the domain of the function to ensure that the inverse is also a function, right? So there are two parts to this question. Let's start with finding inverse of the function, right? So let's do inverse first. Now to find the inverse of the function, what we should do is we should swap x and y values, right? And then solve for y. So the function given to us is y equals to x plus 1 whole square. Let's write down the function first. It is y equals to x plus 1 whole square. And now let's swap. So if we swap x and y values, then we get x equals to y plus 1 whole square. And let's solve for y. And then we solve for y, right? So it becomes, let's square root both sides. Once you do square root, you get plus and minus square root of x equals to y plus 1, or y is equals to minus 1 plus and minus square root of x. Now as you know, there are two values for every x, right? So that means the inverse is not a function. And from here we can write down that the inverse, or we can say y inverse, is actually equals to minus 1 plus and minus square root of x. So that is how we can get inverse of the function. Now let's try to sketch this inverse on the graph itself. So we do have a function here which is y equals to x plus 1 whole square. Parabola shifted 1 unit left, right? Now to find its inverse graphically, let's use the technique of swapping x and y. So this point is minus 1, 0. It comes to 0 and minus 1. So we have this point here, and that is 0 and 1. So it should get reflected, and it will be here, right? So there are a couple of ways to do it. So we'll explore all the ways. There's a couple of different ways here to do it. So let me draw this line, and this line which I'm sketching here is actually y equals to x, right? Now what we'll do is we are going to reflect. So from here, if I go half, half, right? Now a good point to take is this one, right? So at 1, the value is 4. So the inverse should be 4 and 1. So that is the point, right? We can also get it directly from the graph. If you move diagonally, 1 and a half, half and 1, so you get to that point. Do you see that? So let's draw the upper half in this red color, right? So that becomes the upper half of our function. So this basically is starting with minus 1, right? So it is minus 1 plus square root of x. So that is the upper half. Now let's look into the lower half, or the left side of the graph and its inverse. On the left side we have minus 1, 0, which is here, and then we have minus 2 and 1. So minus 2 and 1, if I go diagonally, 1 and a half, half and 1. So we get to this point, right? And this is indeed 1 and minus 2. So that works, right? Now this is the point which is at minus 3 and the value is 4. So if you swap it, it should become 4 and minus 3. So 4, 1, 2, 3. That should be the next point, right? You can count diagonally also. 1, 2, 3 and a half. Half, 1, 2, 3. That's it. Now let's join these points and get the parabola. So this half is the lower half, right? Which is minus 1 minus square root of x. You see that? That is how we get the inverse of our function. I have purposely divided into two different colors to show you that we could restrict the domain of the function to ensure that the inverse is also a function. Now answering the next part, that is restriction, right? How can we restrict the domain of the function So restriction on domain, right? That will help us to ensure that the inverse is also a function. So the restriction could be that we could have x as greater than equal to minus 1, or we could do x less than equals to minus 1. Either one could help us, right? So if we consider x greater than equal to minus 1, what do we get? We get the upper half of the graph, right? So in this case, we only get the upper half of the graph. And in this case, we get the lower half of the graph, correct? And both individually will be functions. Since the vertical line drawn here will not cross both of them, because we are considering only one half of the inverse. You get the idea. So that is how we could restrict the domain and ensure that the inverse of the function is also a function. Now at this moment, I'll also like you to look at the figure nicely and carefully, so that if I change the question, if I want you to write inverse of only minus 1 minus square root x, what should you answer it as? What is inverse of minus 1 minus square root x? It is the left half of the parabola. Do you see that? It is y equals to x plus 1 whole square, where x is less than equal to minus 1. Similarly, what is the inverse of minus 1 plus square root x? Inverse of this function is the right half of your parabola y equals to x plus 1 whole square. Do you understand that part? It's kind of critical. So we'll get into this also in the coming videos. Thanks, and I hope you're enjoying the process. Let's move on and see a transformed quadratic function, both transformations on x and y axis. Thank you.